Okay, let's go.
Yep. Perfect. Cool. So what is A/B testing? A/B testing has been known by actually multiple different names. You can hear terminologies like split testing, conversion rate optimization. Some other people call it digital optimization or growth hacking. All of these kind of names refer to the same thing. So A/B testing is a research or randomized experimentation technique where you have two different variants of the same digital experience, variant A and variant B. And you're trying to find out which variant will resonate more with your end users, or which one will have a higher conversion rate. So in different words, A/B testing is kind of like an experiment where you have random visitors coming to your digital property. Then you show them a different version than the original one. The original one, usually we call it control. So for example, if you have a machine learning model powering your recommendation engine, and your data scientists decided to build another model using a new algorithm that they think that it might be better understand the user needs. So the way to go about testing his hypothesis is by doing an A/B testing that measures some business metrics out of this test. So at the end of the experiment, you can then decide to either accept his hypothesis or completely reject it. So the main benefit of A/B testing is that you can actually impact your bottom line and increase conversion or revenue in multiple different ways. And there are multiple case studies that I suggest that if you have time, you would read on, like Netflix with a recommendation engine user experience, which is like, it's a really interesting case that shows how A/B testing has improved retention and increased revenue. So by running A/B tests, another benefit to run it, that is the ability to do rapid iteration, that you can implement new experiments much faster. So, sorry, let me switch. Yep. So apart from having rapid iterations, there are many different benefits from doing it. And as I mentioned before, one reason is increasing conversion rate, which would potentially reflect back on the revenue. One other reason why A/B testing is so powerful is that your users don't really know that they are in a test. They're randomly assigned, and they are your real life kind of users going through your digital experience, right? So they don't know that they're being tested, which is really important because it gives an unbiased view of the experiment or the whole experience. And by using data directly from your users, you're able to eliminate any kind of guesses, biases, or opinions that usually goes into building any digital experience. So this is really important in financial services specifically, because this is one of the most highly regulated industries. Another benefit is that you're able to do rapid iteration. So you can implement new experiences, and whether it wins or loses, you can do it quickly. So you win quickly and get gains, or you can lose quickly and iterate fast and move on. And you learn what doesn't work for your users. So you're not just going out and asking people what they think. Your actual users who come to your digital properties are telling you what works and what doesn't work. So you're letting your data and your users guide your decisions and the next potential investments. So I want to go through some of the concepts that you need to fully understand in order to know the statistics behind A/B testing a bit more. Number one is test population. So this is basically all of the potential users of visitors to your digital property. The total whole of all of the people in question with your website or the model that you have. Those are the potential visitors or potential consumers for machine learning models. Number two is sample size. So with any testing, we use a sample size, and the sample is simply a subset of the entire population. So with A/B testing, your sample can be 100% of the people consuming your model or visiting your website. And the more you limit the sample, the less confidence you have in your data. Another really important factor when deciding about the sample size or the sample is that your sample has to be random, just to avoid any kind of bias, and it has to be representative of the total population. Otherwise, you will have or introduce some kind of bias in your test outcomes. So the larger that you can make your sample size, the more representative it can be. The other concept, or the third one, is called left. And this is something that you're probably going to hear a lot when you do A/B testing, or you're going to see it a lot in A/B testing tools. The lift measures the increase or the decrease in the change or the conversion rate. So it's basically checking the conversion rate. Is it getting better or worse? And if it's getting better, by how much? So it's really important measure that tells you if the variation that that you're testing is better or worse than the control. And the calculation for it is quite simple. So it's the new conversion rate minus the old conversion rate divided by the old conversion rate. So the next concept here is called statistical significance, or just significance. Statistical significance is a way to interpret the statistics behind your results. It basically means if you were to repeat this test, what is the likelihood that you'd see the same results again? So for example, if you have 90% confidence, you can say that if we would rerun this test, then 90% of the time we would expect the same results. So actually, if you plot the statistical significance in a graph, you will see that it is constantly going up and down. This is basically because up and down over time, of course. This is basically because as you get more of your samples over time, the conversion rate is calculated by taking your total leads divided by the total visitors in the test, which ends up giving you the conversion rate or the average data points that you're looking at. So just the more people visiting your website, the more kind of confidence, or the more solidifies the statistical significance that you can extract or get out of this test. So if you have a low significance, then the test is not likely a winner. And if you have a high significance, then this variant is likely to be a winner. However, you shouldn't really count on this number alone. And there are many other ways to interpret the test results, something like the p-value or confidence intervals, which is not actually covered in the scope of this session, but it's really, really important to combine multiple different metrics in order to make a decision about whether or not the test is good or bad, or whether or not to reject this null hypothesis. Also, because we do A/B testing on a sample of the population, we have another metric called confidence interval. This is basically the range of expected outcomes. So let me give you an example. Let's assume that you have significance or statistical significance of 90%. And if your confidence interval is about 5%, then and the conversion rate is about 20% after the test, then that tells you that we are 90% confident that the conversion rate is plus or minus 5% of the number, which is 20% conversion. right? So it kind of like gives you an idea what would be the upper bound and lower bound that the conversion rate can go below or above the number that you averaged or decided on. So this is an example that I actually found online on control variation testing. So in this mission, to maximize conversions, you can see that the control here has a conversion rate of 50.99%. And the first variation is 54 plus or minus 5. So this is a confidence interval. Plus or minus 5% of this number can be the conversion rate, and the same for variation 2. And this confidence interval shows you, tells you that even though this number is much higher than the control, it can actually go below the control at some points. So maybe it's not worth to go to that variation because the statistical significance is not quite high. But this one, even the lower band here, you're going to go to 71% conversion rate, which is much, much higher than the upper band of the control variation. So it might be worth going or having a look at variation 2 of the model or whatever you're experimenting with. So again, there is a cost that you incur as you go in that kind of mission to maximize conversion. There's a sizable portion of your traffic is routed to a losing variant. So for example, we're routing the traffic equally between all 3 variants, and part of the traffic that goes to the control and variant 1 or the first variation is actually losing conversion. This is indirectly reducing business metrics like sales or whatever you call it, conversion maybe. And I'll show you why in a second. But before we do this, let's explore some of the machine learning concepts and how this kind of testing can apply to machine learning. So machine learning lifecycle, I'm pretty sure that most of you might be familiar with this kind of lifecycle. So once you start looking at one of the machine learning problems, you think about what are the business problems that we're trying to solve here. So you frame your problem in a question that you try to answer through building this machine learning model and using this specific data. After you frame that problem, you try to find the relevant data that you need to collect in order to build on and solve that problem. And then once you find the data, you decide about what machine learning algorithm that you want to use. You do feature selection, feature engineering, prepare the data in the right format for that model, that algorithm, and then go for model training. After you train your model, you do model evaluation. So you evaluate your model against a holdout data set or a data set that you test data set, sometimes called test data set. And then after that, if you already have a variation of that model already deployed in production, and you want to make a decision whether to deploy the new model or not, it should not be just based on the evaluation of the model based on the test data, because the data is quite dynamic and can change over time. So you need to deploy or apply some kind of testing mechanism to see whether or not the new model is going to outperform the existing one. Sometimes I've seen in situations where the model evaluation on the holdout data set can give you better performance or better metrics. But when we actually do A/B testing, the conversion rate is much less due to a lot of external factors. So, and these external factors are not actually included in your training. So it's really important to do these 2 steps of evaluation and testing right next to each other. And once you're happy with the model, then next step will be the model deployment. And then the cycle goes back again if you detected any kind of drift in your data set. So from here, let me just dive a little bit deeper and give you kind of like a scenario of a real life situation that may happen when building a new model. So, for example, we have Bob. Bob is a data scientist who works for a fictitious company, XYZ, which is an online retailer and an e-commerce website. End of year sale is coming up soon, and to fire up demands and trigger wildfire sales, the company that is called XYZ decided to run flash sale on a variety of its products. And that flash sale is only going to go for 3 days because it's just happening because of certain season of the year. So here's a catch. Bob knows that the model XYZ that's being used for recommendations is quite poor and is mainly based on item similarity. So it's really basic. It's been built for a long time ago, and it hasn't been updated so far. And doesn't really consider seasonality, for example, or clickstream information or user historical data or anything like that. And in order to improve the recommendations engine, he created a much more kind of like advanced algorithm to do the recommendations. Then he decided to do an experiment where he created a variation of that new model, promoting just to promote the flash sale. And then shortly, Bob wants to he just want to improve a crucial KPI for him, which is the discoverability, or for the business, which is discoverability, improving discoverability through a better recommendation engine, and consequently, that would increase the number of sales. So Bob is looking at the incoming data from the experiments, and he observes that the new advanced recommendation model is demonstrating a strong uplift. So Bob got super excited. He wants to share some early results with the senior leadership team and get them quite excited. But just as he's about to barge in and with a copy of the early trends to convince his manager, he's being stopped by a quip from model validators and model analysts. So the model the model analysts or the model validators, they see the new trends and they're like, yeah, that looks great, but where's my statistical significance? Where's the significance number? Then Bob replies back saying, we don't really have to wait for it. The sale is going to end in literally a couple of days. So who do you think is right in this situation? Bob, who wants to meet his KPIs and do the best he can in 3 days, or the data analyst who's in questioning for the statistical significance? Actually, from my point of view, both of them are right. So if you remember from earlier slides, there is a cost associated with doing any A/B test, which is the loss of conversion due to the low performing variation. This loss of conversion is called Bayesian regret. So minimizing this regret is really important in time-sensitive situations or in cases where the cost of poor variations is quite high or high enough that the businesses become skeptical to run an A/B test. So since Bob is relying on 3 days window to maximize its sales, he can't really wait for statistical significance, which usually takes much more time. I would say some situations weeks or months, depending on the traffic that comes to the website. And if you remember that graph that I showed you in the statistical significance, this is 100% based on how much traffic do you receive in your website. You can literally wait for months in order to get a stable, kind of solid statistical significance from the test. So if he waits for statistical significance, he won't be able to use the results as the 3-day window will be over. So the solution to this specific problem is to use the Multi-Armed Bandit algorithm, which is in short for MAP. I don't want to say multi-armed bandits every time I want to mention it. So MAP is an A/B testing strategy that uses machine learning in order to learn from data that we gathered during the testing to dynamically increase the number of visitor allocation in favor of better performing variation, right? So what this means is that the variations that are not good, they're going to get less traffic, less and less traffic allocation over time. And the good variation would get more traffic. This concept is similar to, if you studied statistics before, this is similar to what we call dynamic traffic allocation, which follows very similar kind of approach. So unlike standard A/B testing, MAP guarantees that the total number of conversions will be maximized while carrying out the test. So the trade-off here is that the statistical certainty in the A/B test is going to take a backseat here because the focus is going to be on the conversion, but at the same time, it doesn't eliminate that that statistical significance. We're still going to be able to determine that and get that out of the test or at the end of the test, while increasing the conversion rate at the same time. Cool. Let me just click here. So to understand MAP better, you should know that there are two different components that powers this specific algorithm: exploration and exploitation. So most of the standard A/B tests are by design in exploration mode almost forever. And after all, like determining statistically significant results is the reason for existence. So in A/B tests, the focus is on discovering the exact conversion rate of variations. It also adds a little bit of twist to A/B testing, which is exploitation. So owning to the maximum conversions and profit texture of MAP, exploitation and exploration run in parallel. So think of the algorithm exploring at a rate of many visitors per second, arriving at constantly shifting winning baselines and continuously allocating the majority of the traffic dynamically to the winning variant. Okay, I think that concept sounds a little bit more clear now. So as you can see here from that graph, when you run the standard A/B test, you have the traffic equally divided between all of the variants. And when you use the multi-armed bandits, it starts to shifting the traffic to the most valuable or the most rewarding variation or variant in this case. So option one is going to get much more traffic, and consequently it's going to increase the conversion rate while you do that. Cool. So over the test cycle, the algorithm tries also to balance between the two pillars, so the concepts that we just discussed, the exploration and exploitation phases. So this is really important to remember. So when or why should we use MAP over A/B testing? You should use MAP when the opportunity cost of lost convergence is quite high. So imagine that, for example, you're selling a car online. Each lost conversion is probably worth thousands of dollars in lost opportunity for you. So in that case, MAP's focus is on maximizing conversion, is a perfect fit for the optimization of the website, right? If the conversion rate that MAP is going to make difference for is quite low, then it may not be worth all of the efforts to use it with the A/B testing. Optimizing continuous optimization. So if you want to continuously optimize the ability to add or subtract multiple elements from the variations and test across all of the variations simultaneously, then map can be a better way here rather than the traditional or the standard A/B test. The third reason would be optimizing revenue with low traffic. So if you don't have a lot of traffic coming through, then waiting for something like statistical significance is going to take a lot of time. So using map in that case with low traffic, it's going to help you redirect the traffic to the best kind of model here to increase the conversion rate while waiting for the significance to be built up. Again, if we put it in a financial services industry kind of context and thinking about use cases like fraud detection, so if you have two models, one that somehow returns a high rate of false positive and false negative results, and now you have a better model, better algorithm, or more data that you trained on, and you want to deploy another model and test it in production. So that can be really critical for you, because a very high false positive might create a lot of sentiment for the users, because maybe you take an action by blocking transactions based on the fraud, the automatic fraud, or the false negative is going to translate directly into revenue loss, which, you know, if you translate that into financial terms or monetary kind of terms. So yeah, that's when you should actually use map. There are some situations where A/B testing can clearly be a better choice here. So number one is when you're aiming for statistical significance in a short period of time, then the standard A/B test can be a better kind of solution here. When you optimize for multiple metrics, so if you have multiple different metrics that you optimize for, then A/B testing or the standard one is definitely a better solution for you. If you're just collecting data rather than making or putting models in production, and these models would actually reflect on revenue. Not every single model reflects on revenue, right? Or reflects on conversion rate. So if you're just doing A/B testing for the sake of collecting data from users and understanding the user behavior, then A/B testing can also be a much simpler approach here.
Well, we're still seeing the MIB slide. Is that right?
No, I'm on a slide that says, when should we use map?
Yeah, okay, fine.
Okay. Yeah, so that summarizes the slides. I hope that was useful. I've been in a lot of situations where we needed to use map just for the sake of building an agent that can understand the user behavior while at the same time getting much better results. So yeah, and some other situations where map implementation was too complicated or overkill for that specific scenario. Map is one of the strategies. There's another thing or algorithm called Contextual Bandits, which is very similar to the map, except for it adds a little bit more context about the users. But in that situation, you're turning from testing all the way into an optimization problem. Then you can put yourself in a dilemma where, oh, what if I can keep both models? What if I can get to a stage where the Contextual Bandits kind of algorithm knows what users to send to the first variation, and what users to send to the second variation based on the preferences. Because since you're going to add a little bit more context about the users and the preferences, then you can actually get to that stage of optimization. So yeah, that concludes what I wanted to cover. I think I'm right on time, Hendrik, if I'm not mistaken.
Yeah. Very good, thank you. Are there So thanks a lot, Will. I thought it was really good presentation. I did learn a decent amount as well, and I think the concept is really interesting as well to optimize the A/B testing space by like optimizing the exploration and exploitation trade-off. Are there any questions directly from the audience that are coming in? There's one with Samat.
Let me have a look at the chat. Can you recommend any implementation packages for map? There is a really good implementation that I've seen before. Just let me find it for you and send it. But yeah, there's multiple different frameworks that you can use to implement map. It's basically reinforcement learning. So any framework that works with reinforcement learning, the top frameworks like PyTorch and TensorFlow can also help you with that. I just found it. Sorry. Here we go.
Hi, Will. I have a question.
Sure.
First of all, thank you so much for a very nice presentation. It was good to learn, and I really like the use of minions in your presentation. It was refreshing. My question is that the example you talked about, the application of it in the fraud side or the risk side, I'm just curious to know whether you have faced some kind of resistance from the model validation team or the compliance side in using these kind of testing mechanisms.
Yes and no. So it depends what the business use case that you're going to try to frame that testing in, and what questions, or sorry, what questions that this testing is going to try to answer, right? So if it's more on, okay, we have a new model and that model is possibly going to yield a little benefits, but this is our hypothesis, and the only way to test it is to put it in production and do the A/B testing. Usually they come back to you with some kind of time frame. Yes, you're okay to go for a certain period of time, and after that time, we need to discuss results and see if we can keep going with that test or not. Sometimes you get a little bit of resistance because you can't really validate that or justify that this test have enough conversion rate to be done, because any test is exposed to some kind of losses, right? Mm-hmm. If you send it to the wrong model, then and that wrong model, not going to give the right results, then you're losing that specific conversion rate. So yeah, it depends on the value of the conversion rate that you're trying to rectify here, and the time that you're going to get assigned to you to run this experiment.
Gotcha. Thank you.
Thank you.
Any other questions from one in the audience directly?
Let me put the chat on. Sorry.
Yeah, there's how do you think about MAB optimization when you need to consider multiple business metrics to determine if a change is successful?
Yeah, that's actually a good one. So if you have multiple metrics, then it's better to go with the A/B testing, because like most of the mature kind of experimentation teams track 3 or 4 plus kind of goals per experiment. And as experiences or experimentations are exposed to primary and secondary goals, and while map experiments work great when optimizing for one key metric, they don't really work well when it comes to multiple goals, and they only factor in the primary goal when allocating the income and traffic. So I wouldn't use MAB in that case. I would look for a different strategy, or just focus on one goal optimize for it, then move on to the second goal. It's usually easy to get that one metric as combined as a composite kind of metric between two different things as well. So if you can define that kind of business metric in a function where it can combine two different metrics, then you can use map. If you can't do that, then the standard A/B test is better in that scenario. Did that answer your question, Derek?
Wait 1 second. Derek, there you go.
Yeah, I mean, it's somewhat, I agree with that. I mean, I've encountered this before, and I think like often you have some kind of trade-off, like, you know, the number of fraudulent transactions you flag versus the number of like successful account signups, right? Or like sometimes you need to weigh these things together. But I also like that idea of, you know, how, if you can put a weight on those different things and expressing some kind of composite metric.
Presumably that's also how you incorporate constraints, right? So having some kind of penalty.
Yeah, yeah, definitely through weights. Yeah.
Any other questions from the audience? I have a question then. So my understanding is, so multi-armed bandits is technique for using various variations to trying to determine dynamically which ones to choose. And then contextual bandits, my understanding is you use information more on the like user context in order to decide which variation to show, right?
Yeah, exactly. If you use contextual bandits in context of A/B testing, they reframe the A/B test questions like what variant works best for everyone, or well, that is the map. When you use contextual bandits, the question here turns into what segment should I show this variant to, right? So it kind of like clusters users based on a lot of context information about the users before it can send the traffic to them. But again, like after some time, it converts from a A/B testing to an optimization problem, where you have two working models. Both of them work really well for the traffic that this agent is sending them to. So yeah, it kind of like transition out of the testing problem and becomes an optimization problem.
Yeah, you have pretty much two optimization layers then, right? So you have the model optimization, then you have the actual, yeah, I guess A/B testing optimization. And similar though to, like, so my understanding is here you use like information from the user to make further decisions. Have you seen anything where you see, yeah, use information from the variants as well? So for machine learning, for example, if like a particular hyperparameter is doing badly, then you do some exploration in that hyperparameter region, and then you would like discount like future variants from that with that hyperparameter space, something in this region. Do you follow what I'm trying to say?
Yeah, but yeah, I see what you mean, but it usually happens before you plan for your test or before you put the test variations together. Because at this stage, you have a model, you did the evaluation on it based on a holdout data set, not based on the traffic that is coming through. So that happens right before you do the evaluation step. I haven't actually seen any scenarios where people use contextual bandits to optimize on based on the information of model internals or hyperparameters. That sounds like a good idea. Yeah.
Okay, cool.
Yeah, usually most of the hyperparameter optimization or the most popular hyperparameter optimization algorithm here is Bayesian optimization, which is one of the algorithms in the optimization family, and actually balances between the exploration and exploitation in a similar way that map does. So it tries to find, it explores around and tries to find the right region for a range of hyperparameters. Then once it finds that, it exploits that range and to increase or maximize the objective function or black box function. So it works in a very, very similar way. It's an optimization algorithm. But again, this is based on a function that you define based on data that you already have, not data that you're expecting to have sometime soon.
So it's some kind of form of like almost online learning in that case, it sounds like.
Exactly, yeah.
Juan had another question. Do we take significance into consideration when doing map?
You can absolutely do that, yeah. But in that case, you're probably going to take or spend much more time to get the statistical significance, because you need to have enough data coming from both variants at some point. Whereas if you have a really poor variant and a really good one, then traffic going to the poorer variant is going to be way, way less than the traffic going to the good one. So calculating the statistical significance has to happen from both variants with a decent amount of traffic. And in order to get that statistical significance, you're probably going to have to wait for a long time when you're using map. So you're not completely losing the statistical significance. As I mentioned before, you're just sending it to sit in the backseat, but you don't really eliminate it.
Mm-hmm. Cool, thank you. Any other questions? Someone in the audience? Do you have some like success stories of like how much like faster you can get the results with this compared to A/B test, what you've seen?
Yeah, I think Netflix has published a really good case study about using bandits from memory on A/B testing. I'm just going to need to try to find it. But internally within Amazon, we use A/B testing using MAB as well for some certain use cases when we publish a new model. But this is one way that we do testing with. There are definitely multiple different ways as well, based on the team and the business use case and what actually we're trying to test, what question we're trying to answer with that test. So this is just a really smart way to optimize it. It's kind of like using machine learning on top of machine learning, but it's definitely worth trying initially. I'll try to find that Netflix use case and send it to you. It's really good case study.
Cool, yeah, looking forward to it. Any other questions from the audience? Doesn't look like the case.
I found a blog post that talks about this case study, but I need to find the official kind of blog from Netflix.
Mm-hmm.
Oh yeah, here we go. Artwork personalization at Netflix.
Cool, thank you. Cool, then I think we come to the end of the session. Is there anything that you want to plug? I think you also have a blog. Maybe you want to share some words about it?
Oh yeah, sure. It's on Medium. So yeah, I keep writing about interesting topics like these ones. So feel free to have a look at this blog, posts that I publish from time to time. But thanks so much for the invite, Hendrik. It's been my absolute pleasure talking to everyone in the group, and looking forward to come back again.
Yeah, love to you, and I thought it was a really good discussion afterwards. Thanks a lot for coming, Will. I really appreciate it.
Thank you, and apologies again for that.
I don't know, it was probably my fault. So yeah, I'm very sorry for that as well.
No, no
But yeah.
problem at all. All right. Thank you. Take care. Thanks, everybody. Bye-bye.